Hello, I'm Peng Wang. My supervisor is Professor Ziqiang Zhu. I'm from Sheffield University, and I just finished my PhD thesis this year, March. The title today is Online Parameter Identification of Permanent Magnet Synchronous Machines under Sensorless Control. The project overview is doing research about the permanent magnet synchronous machines. The outside is the stator, the inner is the rotor. It has many applications in transportation, electrification, renewable energy generation. When the machine is running, the parameters are very important for the operation of the machines, like the inductance, resistance, PM flux linkage. They have many applications like PR, parameter setting of current loop, maximum torque per ampere control, improved position observation. These parameters have many applications, so we need to estimate them. My research is focused on the generator control because my project is sponsored by Siemens Gamesa. My research is focused on the parameter estimation and the sensorless control. About the online parameter estimation, the parameters would change with the operating state, so we need to estimate them in a real time. We utilize the sampled voltage, current, and speed to estimate the parameters like the inverter nonlinearity voltage, stator resistance, DQX inductance, and permanent magnet flux linkage. But we can find that with two equations, we need to estimate about 5 unknown parameters. So less equation, more parameters, it will have the rank deficiency problem. Normally, we would inject the signals to solve the rank deficiency problem. Under sensor control, we have many ways to solve the rank deficiency problem. This research has been in a mature field for about 20 years. But my research is under sensorless control to do the parameter estimation. We utilized the sampled voltage and current to estimate the position. So not only it will have the rank deficiency, but because the position is estimated, it will have another unknown parameter, position error. So sensorless control will have the position error will influence the accuracy of the parameter estimation. It will cause the inaccurate of the parameters. So the two parts, sensor control and parameter, will have the transfer influence. At last, it is very hard to guarantee the convergence of the online parameter estimation. As we can see, with the increase of the position error, the parameters will have the mismatch with the nominal one. So we need to develop a sensorless controlled online parameter identification for megawatt generator. Today, I would introduce the 4 topics. Position offset injector parameters. Second is the virtual signal injection. Third one is the application in dual three-phase machine. Last one is the application in offshore wind. First is the position offset injection. About the position offset injection, we can inject the square wave position offset into our estimated position. We can find that the Q-axis voltage fluctuation can be controlled to estimate the inductance and the resistance, and then permanent magnet flux linkage is estimated from the back EMF. It's a generator control model. In the motor control, the outside will have the speed loop, so we can extend the generator model to the motor model. It's our application based on this research. The disadvantage is that it can only applicable to the closed loop estimation. It means the parameters need to feedback to the position observer, no open loop estimation. So we want the open loop estimation. That's why we propose the virtual signal injection parameters estimation. About the virtual signal injection, not like the position offset injection to inject the position offset into the estimated position directly, the position can be extracted from the flux linkage and the back EMF. So we can inject the signal into the flux linkage and observe the back EMF. It's an indirect position offset injection. The advantage is that the position error doesn't vary with the injection of the virtual signal. So the position error doesn't vary. It can guarantee that with the virtual signal injection, the number of the parameters won't change. So the 5 after the injection is still 5. The virtual signal injection is the novel injection method proposed in our research group. For example, the virtual back EMF injection, after the 0 positive and negative injection, it will have the position offset response. We sampled the speed, voltage, and current to estimate these parameters. This is our test bench. Downscaled representative went by PM generator control system. We utilize the sampled data, inject virtual back EMF, current, voltage. As we can see, even though now it has the position error, but we can still estimate these parameters accurately, totally cancel influence of the position error and the inverter nonlinearity. The summary of the virtual signal injection is that we can try to extend the application, the virtual back EMF to the virtual extended back EMF, virtual flux linkage, virtual active flux linkage. The application scope comes from the surface-mounted PM SM and high-speed to surface-mounted and interior permanent magnet machine and low and high speed. So try to extend the application range. The third one is about the parameter estimation in dual three-phase machines. About the dual three-phase machine, it will have the dual three-phase windings A, B, C, X, Y, Z. They are controlled by separate three-phase inverters. It has many advantages compared to the three-phase machine, like the high fault tolerance, reduced torque ripple, improved harmonic suppression ability. For example, I can extend the method into the dual three-phase, utilize the dual three-phase characteristic. I only inject the square wave virtual back EMF into one set, the one position observer. So we control the sum of the Q-axis voltages in both sets to estimate the resistance and the inductance. The torque ripple is reduced by about 50%. Another is the virtual signal injection. We inject positive in one set, negative in another set. We utilize the voltage difference between two sets to estimate the permanent magnet flux linkage and then to extract the PM temperature. This injection sequence, positive and negative, has no any influence on the torque output. The last is application in offshore wind. After developing many methods, we can extend our developed methods to the megawatt machines. We extend our developed methods into the 4 megawatt machines. The rated current is 4 kiloampere. So it will have the strong magnetic saturation and cross-coupling influence. Some of the methods are not suitable for the megawatt generators. So we developed the resistance estimation method can be applicable to the megawatt machines. We have applied for a European patent. The proposed static resistance estimation method can be applicable to three-phase and dual three-phase machines. The influence of the nonlinearity magnetic saturation is cancelled, and also the position error. In the three-phase machine, it will have the torque ripple, but in the dual three-phase, the torque ripple can be cancelled. The summary is that we proposed the position offset injection, a series of the virtual signal injection can solve the influence of position error on parameter estimation. And also, we can extend our proposed method to offshore wind power applications. It's the publication list of my PhD research, 1 European patent and 10 first author IEEE journal paper are published. Another 2 IEEE papers are under review. Thank you.